Welcome to Geometry. This is Mr. O'Shea. Today we're going to be jumping into 2.1. It's our new chapter, Chapter 2, and we're going to start off talking about conditional statements. And conditional statements, it's really going to be our prep to our logic unit. So this whole chapter is going to be based off logic. So a conditional statement, what is it? Well, it's basically just going to be any type of statement that's written in if-then form. So it could be anything, any type of statement, just so long as it's written specifically in this if-then form. So here's an example, right? If your feet smell and your nose runs, then you're built upside down, right? Follows that if-then statement. A hypothesis. What a hypothesis is, that is going to be the part of the conditional statement. So it's the part of the conditional that follows the if. It's your beginning piece. The hypothesis follows the if. And this is really key because a hypothesis, that really supplies us with our given information. Or maybe our condition. Now we've got a second part to it. Oh, sorry about that. We've got a second part to it, and that's called our conclusion. And the conclusion now, well, that's going to be the part of the conditional. It's the part of the conditional. This one, it's the second part. It's the part that follows the then. And the conclusion, well, really, I mean, it's basically what it sounds like. It's the result of the given information. Alright, so let's pick out the hypothesis and the conclusion real quick. If today is the first day of fall, then the month is September. So the hypothesis follows the if. So all the piece that follows the if. Today is the first day of fall. So today is the first day of fall. And again, we knew that was the hypothesis because it followed the if. The conclusion, then we got all that other piece. So the month is September. Hypothesis again was today is the first day of fall. Conclusion follows the then. The month is September. Do another one real quick here. Hypothesis, it follows the if. Two lines are parallel. So two lines are parallel. That's the given information. Well, anytime we're given that information, we can make a conclusion. The result is that the lines are coplanar. So again, if we're given two lines are parallel, well, the result is that they are coplanar. Sometimes they're not actually written for us all nice and neat, though, in a conditional form. We'll just be given a statement. A rectangle has 4 right angles. We know that's a true statement, but we have to write it as a conditional. So we need to transport this into if-then kind of logic. So these might look a little different, but it should kind of follow the same pattern. If a shape is a rectangle, so we took that rectangle idea, well, then it has 4 right angles. So we took the information that we had, we translated it into an if-then statement. If a shape is a rectangle, then it has 4 right angles. A tiger is an animal. Well, if-then, right? So if well, let's change this. If something is a tiger. Some of these are kind of hard to do too, so you got to kind of think a little outside the box, right? If something is a tiger, well, then it is an animal. It's pretty basic. Anything that is a tiger is definitely an animal. All right. Uh-oh. I need a big warning for you guys here. Okay. I'm going to draw your guys' attention to something. These conditionals that we're dealing with, they can be one of two things. They can be true, or they can be false. And sometimes we're going to have to prove them. Now, to show that a conditional is true, we must show that every time the hypothesis is true, we must show that every time the hypothesis is true, the conclusion, well, that's also true. If that's the case, then we have a true conditional. So the beginning piece, if that's true, and the conclusion, the second piece is also true, we know that our conditional is true. However, to show that a conditional is false, all you need to find is one, just one, counterexample. And in this counterexample, the hypothesis is true and the condition is false. So let's look at one. Is this conditional false? If it is February, then there are only 28 days in the month. Well, that makes sense, right? It's 28 days in the month. You might think it's true, but indeed, February of good old 2012, everyone remembers that great 2012 February, right? Serves as a counterexample. Why? Why does February of 2012 serve as a counterexample? Well, for one huge important reason. That was a leap year. And leap years, February doesn't have 28 days. In fact, it has 29 days. So this conditional here, the whole conditional, is a false conditional. All right, we're going to do symbolic logic. We're going to kind of shorten it up, save us a little time here. So hypothesis sometimes, we're just going to represent those with the lowercase letter p. And conclusions, the second piece, we're going to represent that with a lowercase q. So you guys will see this a lot, p's and q's. P is hypothesis, q is conclusion. So normally we have if, hypothesis, then conclusion. If we want to write this as symbols, we said hypothesis was P. So it's going to be P, arrow, Q. And we don't read it as P, arrow, Q. We read it as if P, then Q. So that little arrow kind of means like if, then. All right, so we've got P, the sun is shining. Q, I will swim after school. And then we've got P, arrow, Q, but that's really meaning if P, if the sun is shining. Then Q, well, it was then I will swim after school. So P, arrow, Q again, that really just means, if P, then Q. So we're going to fill it out. What P was, what Q was. All right, the converse of a conditional. Converse is slightly different here. So we talked about what a conditional was. It was an if-then statement. It had a hypothesis and a conclusion. The converse, all this does is it switches the order of a conditional. It switches, to be a little bit more specific, we're going to say it switches the order of the hypothesis and the conclusion. So if I ask you guys, hey, what's the converse of this statement? Well, all you got to do is switch the hypothesis and the conclusion. Now, we're used to seeing it if P, then Q. That's hypothesis, then conclusion. Well, conditional is going to be if Q, then P. So we're really just taking the ifs and the thens and really switching like the order of it all. So let's look at a little example here. Go back to that one, the sun is shining. If the sun is shining, then I will swim after school. we're going to write the converse of it. So all we're going to do is take the two pieces and switch the order. So we're really going to start off with the I will swim after school, right? Instead of writing it if P then Q, we want to write it as if Q then P. So if I will swim after school, then the sun is shining. Again, we're listing the converse of that statement, and all you do is switch the hypothesis and the conclusion. So if an angle is a right angle, then it measures 90 degrees. The converse would be, we have to switch those, so let's word this pretty good here. If an angle, let's clean that up. If an angle, switch, put the conclusion first. If an angle measures 90 degrees, so we followed the then, right? Now we have to switch the order. Then the angle is a right angle. So we're kind of flipping that whole logic there. Again, all we did, flip the order of what is actually written. If an angle measures 120 degrees, then it is obtuse. So if an angle is obtuse, then it measures, then the angle is 120 degrees. Wait a second. That doesn't necessarily make sense, does it? If an angle is obtuse, does it have to be 120 degrees? Now, if we look at the example, though, if an angle measures 120 degrees, then it is obtuse. That makes sense. But then when we wrote our converse there, it actually didn't make sense. So I've got another warning, right? Even though the conditional might be true, like in that last example, sometimes the converse might be false. So even though the conditional in that last one was true, the converse was in fact false. And you guys are going to actually be asked to find that a lot, you know. Is this converse true? Is this converse false? So let's go ahead and do one now. If a figure is a square, then it has four sides. So the converse of that statement, all we're doing is flipping the hypothesis and the conclusion. The converse is going to be if a shape, or we'll say if a figure has four sides, then it is a square. All we did is flipped it. And we'll be asked now, is that converse, is it a true statement or a false statement? All we have to do is find one counterexample to make it false. And we've got one. It's false. You can think of a lot of different ones, but the one that popped into my mind, what about a trapezoid? Right? If a figure has four sides, then it's a square. Well, a trapezoid has four sides, and it is definitely not a square. So there's our counterexample. We just proved that whole converse false. Even though the conditional is true, the converse could be false, right? There's a little picture of a trapezoid just to prove it a little bit more. All right, that was your introduction lesson to logic. Let's go ahead and close this down. I will see you all in class. Come with notes, come with questions, be prepared. This will be a really fun chapter for us.